Cross-validation in Python, Beginner Guide. Welcome! In this lesson, we will learn about cross-validation using Python. You will see how splitting data improves models. We will use real data and simple code. Let us get started. Running the cell now. First, we need to import libraries. We will use the warnings library to hide warning messages. Pandas helps us handle data in tables. NumPy helps us with numbers and math. Running the cell now. Why cross-validation? Cross-validation helps check if a machine learning model is really good. It splits our data into pieces. Each piece gets a turn for testing. This helps us avoid mistakes like overfitting. Running the cell now. Let us load some data to use for our cross-validation lesson. We will use the Titanic dataset. Each row is one passenger. We load the data from a web link. We save it in a Pandas data frame for easy viewing. This print shows how many rows and columns we have. This shows the first 5 passengers so you can see what is inside. Running the cell now. Our goal is to predict who survived the Titanic. Let us see how many survived versus did not by making a bar chart. Running the cell now. Try to imagine why this balance matters for our model. What is train_test_split? Often, we split our data once for training and once for testing. But one split may not tell the whole story. That is where cross-validation helps. Running the cell now. Here, we pick some columns as input, and survival as what we want to predict. Then, we split into training and testing groups. Training is a bigger part. Random state makes results the same every time. We print sizes so you can see how many are in each group. Running the cell now. We build a simple model to see how it works on our split. This is a logistic regression. It predicts yes or no. We fill missing ages with the average for math to work. Accuracy tells how many our model got right on the test group. Running the cell now. Limitation: only testing once. If we test once, maybe we are lucky or unlucky. Cross-validation repeats the split many times for a better check. Running the cell now. Let us use cross-validation to get a more fair check. This function splits data into 5 folds, or groups. Each group takes a turn for testing. Others are for training. We see the accuracy for each try. At the end, we see the average accuracy. Running the cell now. Change the CV number and see what happens for practice. Let us try a different type of model called a decision tree. This works like a flowchart with choices. We do the same 5-fold cross-validation as before. Now, we can compare to see which model does better on average. Running the cell now. What is KFold? KFold splits our data into K equal groups. Each group takes a turn as the test set. This method is strong because all data gets tested. Running the cell now. Now we will look inside how KFold works by printing fold row IDs. We make a KFold object with 5 folds. Shuffle mixes the data before splitting. For every fold, we see which rows are picked for training and testing. The print shows the first 3 row numbers in each group. Running the cell now. We can check more than just accuracy. Recall checks how well the model catches all people who survived. We changed scoring to recall. Then we print each fold and the average score. Running the cell now. Stratified KFold protects class balance. This keeps survival rate similar in each group. We print the share of survivors in each test split. Notice the numbers stay close together. Running the cell now. Cross-validating preprocessing. Sometimes, we need to clean or scale data. Let us use pipelines to combine steps safely. Running the cell now. Let us set up a pipeline to handle missing values and scale numbers. We build a line of steps, fill blanks, scale numbers, then run the model. Simple imputer fills missing ages with the average. Standard scaler makes numbers have the same range. Then, logistic regression predicts survival. This cross-validation uses every step safely inside each fold. We print the average score. Running the cell now. These tools help avoid errors when working with real data. It is your turn. Let us try changing cross-validation settings. Type in a number of splits to use. We ask you for a number of folds. Next, we change how many CV groups we use based on your answer. This runs logistic regression and prints your picked result. Running the cell now. Notice how higher fold counts mean more turns but fewer rows to test each time. Try different values for practice. Mini project, cross-validating on Titanic. Let us do a mini project. Can we predict survival with more columns? Step 1, pick columns. Step 2, build a pipeline. Step 3, run cross-validation. Running the cell now. Now our features include ticket price and passenger sex. We convert sex to numbers, 0 for male, 1 for female. The pipeline handles missing values and scaling. We cross-validate with 5 splits. This prints the new average accuracy, so we can check if it helps. Running the cell now. Let us see what happens if we skip converting sex to numbers. We run cross-validation. If there is an error, we print the message. This shows why preprocessing can be important before modeling. Running the cell now. Sometimes, we want to see the predicted values, not only scores. Cross_val_predict helps us collect predictions for each row. Here, we look at the first 10 predictions. Running the cell now. Can you guess how many match the real survival? For best results, always shuffle your groups. Setting a random state makes results repeatable. This helps other people get the same answer. Running the cell now. Now we will try running a broken pipeline. Standard scaler needs no missing values. No simple imputer is included this time. If there are blanks, this will fail. The error helps us learn what steps to add to fix it. Running the cell now. Extra tips. Use stratified KFold for balanced classes. Use pipelines to keep things tidy. Practice with more datasets for skill. Remember, practicing small steps grows knowledge. Running the cell now. Let us practice using another powerful model, the random forest. Random forests are teams of small decision trees. We fill blanks, run cross-validation, and print the average result. Try other models or settings for more learning. Running the cell now. Share your results in the comments and remember to subscribe for more Python lessons. Summary: cross-validation key points. Cross-validation splits data into parts, tests many times. Safer than a single train test split. Helps judge how models might do on new data. Use pipelines for clean, fair steps. Real data needs careful cleaning. What will you try with cross-validation next? Running the cell now. Thank you for learning. Graduation cap. Want more hands-on Python? Like, comment, and subscribe for more lessons. Running the cell now.